Hi.
Welcome back to the science lab. Oh, you know, we need to check on that celery experiment and...
Oh yeah.
Oh my gosh.
Oh no, it's gross.
Ooh. Well, it's not as beautiful as we want it to be, but you guys were right. The purple climbed the celery from the jar. So, good guessing, guys.
Cool.
Now, even though we killed it, it did show us capillary action in action, where we have the water molecules sticking together, cohesion, and they are sticking to the celery as they climb, adhesion, and cohesion plus adhesion equals...
I know.
What?
It's capillary action.
It is. It's capillary action. So it wasn't pretty. Science. Ew.
Last week we learned how water molecules are polar, just like magnets, where they have a negative side and a positive side. And this is what allows them to have cohesion and adhesion and climb things like celery, causing capillary action. Now that we know that water molecules are polar, their hydrogen bonds allow them to cohere and adhere, which allows water to be poured. So water molecules are like these little beads. They're hooked together through hydrogen bonds, but it's still, we're gonna pretend this whole thing is water, and I can actually pour this. And when I do pour it, there it is. When I do pour it, it will all pour out just like water does. I lost my hand. There it is. I'm gonna do it. It's gonna happen. Sometimes water is sticky. And then if I bring the cups together, the water stops pouring and it holds still. And then if I raise
That is so cool, Mr. Kyle. I just love that demonstration. And it really is a nice introduction to a really cool mechanism called the siphon. And a siphon is when you have some water and your water is higher in one place and you would like to move your water to a lower place, you can put a straw in, and if we create a little bit of negative pressure here with a syringe, pull some of that water through the straw, we can get it to empty into the other jar. And as long as this water level is higher than this water level, the water will move through the siphon into the lower jar. But if you notice, if I bring them up equal, it will flow back the other direction until the water levels are equal again. That is called equilibrium. And if I bring this one up, it will try to empty until the water is equal to the other jar. Just like when you were pouring the beads back and forth, whichever jar is higher is going to be losing water to whichever jar is lower through the siphon. There are some really cool principles of science involved here. There are four forces at work here. The first force is the cohesion of water, and just like our chain, those water molecules are sticking together and the strength of their hydrogen bond is pulling them through the tube. The second force at work here is the weight of the column of water. If you imagine the midpoint of the tube and you measure the height of the column of water in one tube versus the height of the column of water in the second tube, which tube is longer? The right, column A, or the left, column B? Right, the left one, column B. And because that's a heavier column, gravity is pulling the weight of that column down. So gravity is also in play here. Finally, there is pressure differences in the water in the higher cup versus the water in the lower cup.
Siphons are really cool. This is one of my favorite siphons called a greedy cup siphon. This was invented in about 400 BC as a prank. There was a scientist named Pythagoras. That's the guy. Man, I always forget. Pythagoras. And he was kind of like a college teacher back in those days. And his students were allowed to drink wine, but he noticed some of his students were getting kind of greedy and filling their cups a little too high. So he created this siphon, which works just like this siphon. It's just all in one spot. If you fill your water level up here to level 1, the cup stays full. If you fill it up to level 2, above the opening of the straw, but not above the top of the straw, it will also stay full. But once you fill it to the third line above the top of the straw, the siphon starts. Water will start climbing up the straw and out all the way until it reaches the bottom opening of the straw. Should we try it out?
Yeah, do it.
Okay, here we go. I'm gonna fill up to the first level. My cup is still full. I'm gonna fill it up over the opening of the straw that's near the bottom. No water coming out yet, but I'm gonna get greedy.
Oh no, Mr. Kyle.
And the siphon
You got
starts.
greedy.
I got greedy. The siphon starts and pulls the water out because there was no more air in the top of the straw, and the water column was able to move up and over.
Wow, that's pretty cool, Mr. Kyle.
It's pretty funny, and my pants would have been all wet because I was too greedy. I like pranks.
So this week we are playing with siphons in the classroom, and you might be able to do this at home if you have some tubing. You can use any size container, but the tubing's kind of the trick. And if you don't have a syringe, that's okay, because you can use something else for a little suction to get it going, as long as you're not sharing with a friend. So our challenge in the classroom is to create a 3-tiered siphon. So we'd have one jar up high and one jar just a little lower, and then the final jar will be the lowest. And if we're fast, we can move the water all the way to the little jar, the bottom jar, without having... Now you're going to be careful, because if you start with your syringe up here and you remove it, what's going to happen to the water in this column? What force pulls things down towards the earth? If you answered gravity, you're exactly right. If I pull the syringe off at this point, gravity just lets that water fall back into the cup. So when I'm using the syringe, I have to make sure it's down below the water level, get that started. And then you have to move really fast to get the second one going. Ah! See? It's a little tricky. That's why it's a challenge.
You could do it, Miss Reinfelder. We believe in you.
Tra-la! Success! Okay, for a more real-life application, we're going to go on a little field trip outside. Hi, chinchillas. Hi, ferrets. Come on outside. And every year we kill a pond pump in the turtle pond because in our pond there is turtle poop and there are lots of leaves that fall into the water and the food that the turtles don't eat. So the pump in here has a really tough time staying alive. So when it dies, we have to use siphon action to get the water up over the fence to give the tortoises on the other side a little mud fun. And that's one real life use of siphons. About how long does that take, Mr. Kyle?
Not long at all. Maybe 5 minutes to empty this whole thing.
And I dread to ask this, but how do you get the suction going?
I don't want to talk about it.
And that's the magic of water and siphons.
Bye!
Bye, guys. See you next week.